Okay, good morning and welcome to Advent of Code Day 21. Let me pull up my second monitor here. I was rushing. I had a training this morning and I was like, okay, let me quickly whip up something to eat for after the training. And it took longer than expected. So I thought I had plenty of time, but I still had to rush in. So let me pull up the stream here. Okay. Okay, already. Good morning, Luke. Good morning, Amarde. Welcome, everybody. Yeah, today, step counter. It all started with YouTube account. This morning, I always get like the reminder for Jonathan Paulson. I always check if I have notifications from YouTube. And I saw this morning. Jonathan Paulson, an hour and a half video. Usually this is like 5 to 20 minutes for his video. So I was like, okay, that might be tough. Let's look at the leaderboard, the stats. And I was like, okay, and this was still below 1,000 back then. So I'm afraid today will be very spicy. So this makes me wonder if I will even complete part 1. But let's see what today holds in store for us. I also still need to do part 2 for yesterday. I know what I need to do. Like yesterday I started figuring out the patterns, etc. I just need to reverse. That didn't work, so I was like, okay, I need to work backwards from the goal. And I will do that at some point, but not today, because I think I will need all the time I have for this problem. So yeah. Let's start reading day 21. Step counter. A deceptively easy title, but yeah. Let's hope maybe this is one that I don't find that hard compared to others, but usually it's not that way. Step counter. You manage to catch the airship right as it's dropping someone else off on their all expenses paid trip to Desert Island. It even helpfully drops you off near the gardener and his massive farm. You got the sand flowing again. Great work. Now we just need to wait until we have enough sand to filter the water for Snow Island and we'll have snow again in no time. While you wait, one of the elves that worked with the gardener heard how good you are at solving problems and would like your help. He needs to get his steps in for the day, so he'd like to know which garden plots he can reach with exactly his remaining 64 steps. Okay. He gives you an up-to-date map, your puzzle input, of his starting position as garden plots marked by period and rocks marked by hash. For example, and here it is, okay. The elf starts the starting position S, which also counts as a garden plot. Then he talks... Then he can take one step north, south, east or west, but only onto tiles that are garden plots. This would allow him to reach any of the tiles marked O. Sure. He starts south, okay. Sure. Okay, so the periods are the gardens. Rocks, okay. I was mixing that up in my head. So the rocks are just walls in this case. Okay. Okay, so that's a pathfinding thing then, okay. This would allow him to reach any of the tiles marked O, okay. Then he takes a second step. Since at this point he could be at either tile marked O, his second step would allow him to reach any garden plot that is one step north, south, east or west of any tile that would have reached after the first step. Yes, okay, makes sense. After 2 steps he could get at any of the tiles marked O above, including the starting position, either by going north and south or by going west and east. A single third step leads to even more possibilities. Sure. He will continue like this until his steps for the day have been exhausted. After a total of 6 steps, he could reach any of the garden plots marked O. Sure. So the interesting thing is that the starting position doesn't count initially. only when you can reach them. So that is something to take into consideration here. I think that might be a nice off by 1 error for people. I'm just wondering, did I put the link on Telegram? Yes, I have. Okay, great. And did I put it on Discord? I did that as well. Okay, good. Yes, so this is everything after 6 steps. In this example, if the elf's goal was to get exactly 6 more steps today, he could use them to reach any of 16 garden plots. However, the elf actually needs to get 64 steps today. And the map he's handed you is much larger than the example map. Starting from the garden plot marked S on your map, how many garden plots could the elf reach in exactly 64 steps? Okay. Okay. Sounds simple. Well, not so much. Because I'm thinking this is like branching code. So if you do the naive approach and just spawn a new thread or a new path for every one of them, it's possibly like 64, not even cubed, but yeah, it's big. Like 4 to the power 64, something, worst case. So yeah, that's a lot. So let me just think of all the things that we can do. The thing is, like, if you travel a path, like if you're at a given starting position, once you reach that, all the other things are relative to that, right? So if I take this position and I start here, we get these. So the next steps from here would be the same as if I started from here. And from this case, once this one becomes an option, we've already done this starting point. So there is a lot of caching to do there. So what I'm thinking is, like my instinct says, like, okay, just calculate from every point on the map which other point you can reach and then find like chains, but because like if I do it like this, you can just multiply it, right? What's the starting position after step 3? What do you mean? 1, 2. I'm not sure what you mean there, because the starting position is no longer there, reachable, right? So I'm not sure what you're trying to say, so maybe just spell it out clearly. But my idea was like, if you, for each position, you can't reach it after step 3, yes, but you might be able to reach it again the 4th step, right? So here you can reach it again. But what my idea is probably just for each point, calculate how many others you can reach, but that doesn't take into account unique ones. Because that is basically part of the issue. You need to have everything relative from this point to know how many uniques you can have. So what if I would do a search that lets you find all the places that you can reach in 64 steps? But that's actually what we need to do now. I'm just trying to think, like, is there a way to work in reverse so that you can split up the search space? Because that is basically the issue here. Like, if you want to cache stuff going forward, you need to have the history. Okay, I'm not sure if I'll figure this out, so let's just start working on it and see if we get inspired right now. That's not a view that I want to see. I want to do, I copy this file, day 21. So maybe I'm trying to overcomplicate it for the first part and just need to get the work in right now. Wait, what? Oh, okay, boom. Okay, day 21. We have these ones. Const char start marker is S. Did you complete today's Amart Day? Curious to see how you did. Garden marker is period. Rock marker is hash. Okay. Boom, like this. I'm doing part 1, hope to finish soon. Okay, that's so it's a lot of work. Is what that basically means. Okay, so we have input.toLines.map, and then we want the start marker, garden marker, and the rock marker. For sparse is this, so then we can do I should actually use my new grid thing here. Can I do that? Let me see if that works. Grid, and we do grid is new grid. I had a constructor here, didn't I? No, I did not. Okay, which is fine. Rows is let's make the raw map first. The raw map is this. Map dot length. No, raw map. Goals is raw map 0.length. This. Like this. Okay, let me see how I defined it. Like I said, I haven't used it yet, so it's a private init. Okay, I should have just done init in this case because I haven't written a constructor, so this should be fine. And do I do it like this, or does it need the width? No, this is fine. Okay, so that is my grid. I can have a grid location. Start is sparse. Sparse 0 dot oh wait, what? Okay, like this. And I should probably have a operator here to just public static grid location implicit and this becomes a int. This is just a value tuple int rows int, no row int call like this. This. So now I have an implicit operator, so now I can assign it like this, right? And this needs to be dot first. Actually, it should be single because there can be only one starting thing here. And what I could do is let me do a, because these are hash sets of that. Would that work? An implicit version there. I think so. I could do hash set grid location, start markers, and then we have the garden markers, and then we have the rock markers. And I think I can do it like this. As sparse is, let me just do it like this, as value tuple 3. I think this one should do the implicit conversion here. Will it do? Cannot convert type, generic hash string, hashat, that to collection. Okay, so that needs to be explicit. Let's see. Now I started like 20 minutes ago. Okay, part 1 was simple, part 2 is a bit harder, but just a bit. Okay. Okay, it won't do this. Let me just do it. I thought I could destructure it, but then I would have to change the types, and maybe I just want to change this map logic here. Map as grid location. Let me do it like this, and then we do this becomes a grid location, and let me zoom in a bit so that it's easier to read. And here we do grid location, because this is my helper class that just makes stuff easier. And you can see the implicit operator working here already, which is cool, but let's do it properly like this. So I can do this, and then I can do, so now I actually could have done this. And then we can do map as grid locations. Woohoo! And now the destructuring works. So I can do sparse dot. And the cool thing is, actually, I need to do it like this, so that it becomes even more readable. So let's take this away and just declare 3 hash sets here, like this. And now I can do it like this. So we have 3 hash sets. Don't assign it to sparse, I just do this. And now we have 3 hash sets that are destructured like this. And now it's better to read, no intermediate variable. So now I can do start markers single, and we have the other 2 have already been parsed. So now I can do this up here. This will be start, and we can do hash set grid location, and we do this for the garden garden locations, and rock locations. And now I can do this one, and then we do garden locations and rock locations like this. So now it's all nice and cleaned up. Okay. So now we have all these positions parsed in our new structure with grid location records. And I might want to shorten this name, but for now it's fine. So that's the easy part. So let me just yes. We do IEnumerable grid location, get visitable let's do it like this. I will do grid location current, and let's get a reference to the map as well. With the so this one will be the map, and this one will be the both those locations. I will pass this in just because I think it's better to pass all the data that it needs into a function rather than constantly accessing the global state, so that you can isolate it further if you want and maybe reuse it in a bit. So we have the current location, the grid, this one, and this one. So and in grid I have some helper functions like this, and I actually want to do it like this. IEnumerable grid location get travelable no, get walkable neighbors. Let's do it like this. So we can do var up is up, current wrap is false, throw of error is false. Okay. So now we have logic to try and get these, and basically every one of these that is not equal to our current one will be walkable within the grid. So this just does a basic bounds check. So I can do there is this, if they're not equal to current, yield return there, right? And then we do there is up, this will become right, and we do the same there down, and this one becomes left. Boom. There, need to do this to left, okay? Because I've worked it into a case that if it can't do the stuff that we need to do, it will return the thing that you passed in. So if these aren't equal, it will do that. And I could extend this and do like a hash set location, grid location forbidden. These are our obstacles. So now I can do for each var div in get walkable neighbors current, if not forbidden dot contains there, yield return. So now we've combined the two. So we have two overloads now. And now we don't need to have a special function for this at all. We can just do and we should probably cue the direction and have a scene thing there. And if we use like a priority queue, we should also be able to have one global state for where we visited, because it doesn't make sense to visit the same thing twice. So if we reach a state where we have no other places to go, we can just quit. Let me think. And in grid we have this grid location. What I could also do is have an extension here, so I could do public static IEnumerable grid location accept, and I do IEnumerable grid location this values, and then I do the same hash set grid location exclude, and then I can do for each var location, okay, location in values, if not exclude contains location, like this. Okay. So what I can do is combine the two, so that I can have a history. I can first have the walkable with the fixed obstacles, and then I can do another filter pass against the places that we've traveled before. So let me do a priority queue, and this one basically be grid location queue. And this one would be int for the weight. Do we even need weights here? I don't think so. We could have just a simple queue. Just a queue of grid location. But it needs to know how far away it is. So we do grid location, location, and int steps taken, something like this, right? And we can do q.enqueue, no, and queue, and this one will be start. 0 steps taken. While q.count larger than 0, okay, and then we do kind of like a BFS thing. Then we can also do hash set grid location visited is new, so we can do this. We do current is no, this is a combination like grid location and steps taken. Current is q.dq. Then we do grid.get, this grid.get walkable neighbors for current, and we exclude the rocks. If current dot steps taken smaller than max steps, So we do const int max steps is 64 for this case. And then we keep going. This one will be... Oh, no, we do this. Yeah, we don't need to do the check here. Do we need to? Because basically if we reach that, we don't queue anything else anymore. So okay, let's just leave it for now. There's something with the max steps here that I need to check. When do I do this? So we do for each var option in this. And then we do, oh no, I can actually do var options is dot exclude except visited. Is this my own extension or is this a general extension? This is the general extension. Let me see. I wonder when this one would trigger above it. It's not in a static class, that's the issue. So it doesn't trigger as an extension. Let me see. I thought I was being clever, but I just want to do it like this. Let's see, 21. Yes, okay. For each var option in options. We can do q.enqueue option. Basically, it's this. And then we need to add the current, the steps plus one, right? Current dot steps taken plus one. Okay. This should be it, I think. And then we have console.write line, options, path we can visit, path we can visit in steps. So this is max steps, and this becomes scene.count. Scene visited. Okay, visited.count. That is fine, and I still need to add visited here. So I want to do that as early as possible, so we do visited.add option like this. Okay, so this should basically be part one already, and I should probably test it against the test input and see what the actual values were. So it says why don't they give the answer here already, by the way? But that's fine. What was the count? Oh yeah, 16 for 6, okay. So let's even test conditions require more thinking. Yeah, yes. So let's see. So So let me just test 6, otherwise this. Really? What's the issue here? Ah, it's not a constant. Okay, yeah, you're correct. Well, not really. It's funny that okay, max steps. Test is 6. Max steps P1 is 64. So the test is P1 test becomes this, and this is max steps P1 test. Okay, let's see. Int max steps is test like this. Okay. Let's see what happens. Debug assert. Okay, why is that one up there? Let's run it again. Object reference not set to an instance of an object. Okay, that is cool. Let's see. A is null and B is a row. Where is this coming from? Call stack. How come it's current? Current is null. That's interesting. Current is null. How is null passed there? Okay, let's debug this. Step into. No, that should not be the first thing here. It should be this one. Okay. Okay. But it enters null here, right? Ah, current dot location is null. Okay. So that means that the first thing that we enqueue here, the start is null. Okay, great. So that means that the parsing is not working. So let's see what the parser does. So start markers is 1. Okay, so that is fine. Ah, it never gets... I need to do it like this. Okay. That is fine. Everything's fine. Nothing happened. Okay. So now we should get some data. Okay. Null. Great. This is going swimmingly. Okay, set next statement. Enqueue this. Okay. The current is this location. Okay. Options. Walkable neighbors 0. How come? Current dot location is 5,5. The grid is 11 by 11. The rock locations, let's see, 5. It's interesting. I just want to see this again. So for here, the direction, this is 6,5. It's not, so we return 6,5. Okay. Forbidden, does it contain 6, 5? It does. Now the question is, did I map it correctly? Probably. So this one is 5, 6. Another 6, 5. Okay, this is wrong, I think. 5, 6. Okay. Up, right, down, left. Okay. So I need to make sure that this logic is correct. So plus right, plus down, plus up. Let me make sure that I can catch this here and just catch the basics. And this is the issue because I haven't tested this part yet. I've written this all out when I've written all the other code, but I haven't tested this one yet. So current is 5, 5. So going up would be 4, 5, but it's not. See what I do here? I always need to add, not subtract, because these are negatives. This returns into negative. Okay. There you go. That's one down. This is right. Current is 5, 5, so this becomes 5, 6. That is correct. We can remove that one. This one is down, so this one becomes 6, 5. This is also correct. And this one should become 5, 4. Okay, so now at least we get the 4 bounds. And we can still get 0, 0 answers. That is great. Let's stop this, run it again. Let's see. It gets 0. Interesting. So it has two options here. So this is interesting. How come it said 0? Don't mind me. P1 equals this. Yes, exactly. I noticed it right away. Okay, so now P1 is 29, which seems to be too much. Let me see. And max steps was 6 here? Wow. That's interesting. Let me just print out the map. What I will do is let me do a list of grid location pos int step steps taken is new. So in this case, I can just do that add option, comma current dot steps taken plus 1. And now I want to actually fill in the map. So I will do void print map. So I can do for int row is 0, row smaller than grid.rows, increment row. And do the same for column. Call is 0. I should also turn this into a dictionary, actually. Dictionary of grid, comma int because I've written it in a way that you can only get there once. So let's just do it that way. And then we do steps taken, we add this. Okay, I already had this one wrong, right? That's interesting. Okay, then I can do if, and I need to feed this as well. Have set grid location rocks. So now we can do that try get value grid location current row call like this. Try get value current comma out int step number. And we do console.write actually that number. And this works because it's up to 6 now. So others I will have to code like the decimal number into a color or something. But it's good, we only have to go up to 6 for this. Else if rocks.try get value contains current console.write rock marker, else console.write garden marker like this. Okay, so and then we do console.write line and do an extra one at the end. Boom. And then we do print map, we do steps taken, comma rocks. And I should actually pass in grid like this. Rock locations should be right. Okay. Boom. And now I have no external references to the function. It's like this thing is listening to me, knowing what I need to do. Okay, let's see. So the first time we have those two, that is fine. The second time we get this one and the one below it. Oh no, this is a start marker, yes. Then that shape, okay. The two here, sure. Then for 3, we have it there. This one we already visited, so we don't show it again. This one is new, so I have a 3 here. This one is visited, and this one is new, and this one is new. So far it works. Let's see. So this 5 here, I have a 5 here, but they don't. Which is weird. Because how could he get to this place if he can't get here? Oh wait, you have to exclude. Wait, what? Okay, now it's starting to sink in. Yes, okay. So basically, I need to have every number that's divisible by 6, probably. So I think I can use 6, 3, and 2. But not 1. Does that make sense? I think so. I think I'm onto something. Yes. Because that's 6, 4, 4. Nice. The 2, not the 3. Oh, not the 3. Fuck. Sorry. Dang it. I thought I could have used the 3s as well. So is it just 2, 4, and 6 then? The even numbers. That would work. Because you can always step one back. Okay. But does that mean that the ones with the odd numbers couldn't have gotten there? I don't think so. Okay, so just for shits and giggles, for only even steps is this, where x dot value marked mod 2 equals 0 dot to list. If we do p1 is this. Okay, wait, what? That dot count? Come on. Okay, so that is correct, but I'm not sure if that is a valid way to go about things. Because you could like... No, it's not... Am I onto something here? I don't know. I really don't know. Let me just, for laughs, try... and I need the bigger input. Dang it! Get your puzzle input. This one will be huge, right? Sheesh. Oh, I see clear paths here. I'm just gonna, for fun, just gonna run it. And then I need to do some more thinking. Boom. P1 is now this, okay? I don't think this will work, right? Okay, it works. Okay. This is a nice hack, I think. But I'd say nice, but to be honest, I have no clue where you got this idea about even numbers from. Well, I was just looking at the map. I won't read part 2 of that. Like if I go back to this one. Let's go through. And I take this solution here, right? Something I noticed was, it started off with the 5 here. I was like, okay, this corner, you can't get there if you have not been here, right? And then it dawns on me, they just want to have the positions that you can reach at that interval. Like by taking 6 steps, what is the position that you reach? The issue with being only able to move horizontal or vertical is that you can't get at this in another way. But that might be due to how the paths are constructed. Because I think if you look at, it basically comes down to like Manhattan distance, right? You always need to have an odd number of steps to get there. Because of how you have to move. So by taking every spot that you can reach, tracking the amount of steps that it got there, I noticed that the odd numbers were not in my example, so that's where I came up with it. So first I thought it's like, okay, only stuff that is divisible by the n number of steps. So I thought like, okay, it will be 1, 2, 3, and 6 that I can consider. But then I noticed, no, it's actually just the even numbers. And then it makes sense due to the way it moves. I'm still not 100% sure, but I think that's it, just because of the way you have to move, that there's no way to get to that position in an even number of steps. All smaller even numbers are also reachable in 6 steps, because Elf can go 1 step at a time, so it would work for even number of loops too, right? Yes. Yes. But basically, I think you can just cut up the entire grid here and just ignore every odd number Manhattan's distance away. So like, you could take, if the Manhattan distance to a square is odd, you can't reach it in an even number of steps. So that's Yeah, it's a nice realization. But yeah, let me see what part 2 holds. Huh. The elf seems confused by your answer until he realizes his mistake. He was reading from a list of his favorite numbers that are both perfect squares and cubes, not a step. Wait, what? Okay. Stop scaring me. The actual number of steps he needs to get today is exactly, and that is an odd number. He also points out that the garden plots and rocks are set up so that the map repeats infinitely in every direction. Okay. Yeah. But this is cool because my grid actually implements wrapping functions. So it's no problem for me. My actual logic just makes this work. I can just toggle one parameter and then I have the infinitely looping grid solved. Woohoo! Yay for looking ahead, thinking ahead in this case. But yeah, that it just means that the rock exclusion becomes more difficult because it has to be offset by the location like that. Okay. So I can, yes, I can make this work. Because every spot has to be reflected onto the original location, and then you can still use the same lookups. But there's an additional issue there because I need to also keep track of how many times it wrapped, because like for my contains logic it needs to work differently there. And then I also think there's like a way to map the repeating ones. So I'm thinking like if you would map out the outsides, you can just multiply it from there. Let me see if I would just... I have an idea. I have a pretty great idea, I think. I would just have to see how the index would be. Because if I would map out the entire map and assign the numbers to them, so in how many steps you can get there, I think I might be able to work that out further from there. Oh, so many ideas are going through my head right now. The actual number of steps needed. He also points out that the garden plots and rocks are set up so the map repeats infinitely in every direction. So if you were to look at one additional map width or map height out of the edge of the example map, you would find that it keeps repeating. Okay. This is just a tiny 3 map by 3 map slice of the inexplicably infinite farm layout. Garden plots and rocks repeat as far as you can see. The elf still starts on the middle tile marked S though. Every other repeated S is replaced with a normal garden plot. Sure. 2, 6, 10. Okay. Would be funny if you could find a way how this one scales. Because I'm sure there's actually like a way to factorize this as well. Could the elf reach in that many steps? Okay. Ba-dum-bum-bum. That is not correct actually. I need to have max steps P2 is this. And then I need to have one for the 10 steps. I should probably go for the 51, just to have some, to make sure that it does some funky stuff. Like this. And for 50 we get an answer of this. Okay. My issue just becomes just for funsies. Let's see what happens when I yoink this. Go to part 2. We don't care about this. And we do the max steps. Yeah, let's do the P2. We should never do this, so let's make sure that we are in test mode. Sure. I want to see like the map when it's done those amount of steps. And I should have my print map actually do it in hex. And then I can do like this. I don't remember. Yes, okay. So this is single digit hex. I'm thinking printing double wide. Just like this. X2. And let's do this. And what I now want to do is actually change the input. Okay, did I mess something up? Okay, I think I swallowed one there. Okay, it's fine. Reformat everything. Okay. Let me just make this one bigger. That's annoying. Okay. Probably just change this one already. Boom, and make that one. Yes, like this. The issue becomes that I can no longer see where it would wrap up. Yeah, this becomes hard to read. Let me see. It was 11, right? So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. I think this one should be. No. Was it? It was 11 by 11, right? Then why do I have more here? Yes, okay, 11 by 11. Ah, I printed double wide as well. Okay, never mind. So, okay. So yeah, that checks out. Boom. 1, 2, 3. So this one should then be like this. Right, okay, so this is the original grid repeated. So they alternate odd even like this, right? No. Okay, so this is the center. 1, 2, etc. 7, 8. So 9. Oh, but then it has to traverse this whole thing, and then it becomes. So you can't take this one in isolation. I think you have to take the full those cubes and see how they move, and then you can extend those, because this one is like the C tile. Then this one is like this, but the one that comes after this one will be exactly the same as this relatively, right? Same for this one. Oh no, so every direction it will repeat, but this one will make 2 new directions that have to be computed, I think. So that is basically my reasoning. Like, if I work out this first tile, from that I have the 8 tiles around it. Like the one that goes up here, it will be, after this one runs, everyone after this one I think should be the same as the one below it. But I'm not so sure now. Will it be the one after that one? So like there should be like a stable pattern should emerge at some point, because it will find the same routes every time. Because you start from here, so once you reach, actually it's half this, right? If you look at this point, from this point up is actually 1 tile that will repeat in that way in infinity. Let's see, I was thinking the same and I printed more cells. Either I did something wrong or there's no repetition. Okay. That's interesting. Or it's every n cells. Yeah, that could be. because my thinking is like from the first one going up, you have like the upper half of this one and the bottom half of this one, and that section repeats every time. So there should be a stable pattern forming there, but okay, let's do something stupid. Let's see what happens if I would just... Oh no, I can't even... I'm not even in a state where I can run it that many times. And the thing is, because I think we're pretty effective with how we deal with everything, I think I could actually run it like this if I make the whole logic work. Like, how big was the number? 26 million. That's 26.5 million is still a lot, but something tells me that it's not impossible. I might be wrong there. Console, right line, largest amount of steps. Let's see, and this one would be I shouldn't do this in part one. And I should not print out this one either. Let's see. Largest amount of steps would be steps taken dot max. You can show progress every X steps with percentage to see. I did that and I wasn't impressed. Did you have the same aggressive, you only get to visit each tile once kind of thing? Or? Or did you have like a visited state per branch? Boom, boom, da, 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 boom, boom. Because I'm curious, like for part 2, how long it takes to, how many steps it takes to just map out the map there. Okay, so in 36 we could do those. I have visited state per step for the whole map. A visited state per step for the whole map. Okay, so you do a lot of cloning and memory operations there, so that gets slower, a lot slower as time grows on and your state grows on. That's the only upside of what I did, I think, is just having one visited state. I will only just ever visit one place once. So that makes it somewhat more doable. Because for me, and I do some double bookkeeping here, like I could just add the ones that are an even number here to the steps taken. Like if this one is odd, then add it because I need to add +1. Because I only need to track the odd one, the even ones for part 1, and for part 2 it's the uneven ones. And that's also like an optimization that you can do, since you know that the number of steps has to be odd. You could have your step generator just use combinations of 2 steps. So you start off with from your starting position, you get all walkable neighbors from there, and from that point all onwards, you just take steps of 2, right? Because you don't have to visit any of the even paths. So if you just take like the combination of the 2 and the unique set from that, I'm not sure if it will save a lot, but it's like a chess move, right? Like a smaller version of the horse. You take your position and then like doing 2 moves from that, check which places you could go. That might cut down a bit more even. In this case we need to have the odd ones for part 2. And like I said, I just actually don't need to track the odd ones here, so I can just do if this %2 is 0, since I need to +1 it, then I add the steps taken here, and I could do the same here for part 1, just to make that lighter and faster. And then I don't have to do this one. And this one becomes steps taken that counts, like this. See, so part 1 still works, does less work now. Is 29 correct? I know, I actually write out the wrong thing here. Steps taken, or suggest P1. Okay. $7.29. Okay. So my logic here doesn't work, I think. Oh no, I exhausted the square there. That was the issue. I only made a 3x3, and I exhausted all the moves in that way. And while this was fun, I should not do it like this and have a working implementation that just works off of the input map and then transforms that, or allows us to use that. So let me see. I can just do input this. Okay. So now for me to be able to this one needs to be a, I need to have the wrap functionality here. But I should also probably indicate if it wrapped. Well, not really. Let me think. Because what I need to do is actually still know the unique value there. Actually, let me think. The thing is, what I should do is find a way to be able to find how much it changes, or how I should be able to map out these maps and see if I can do something about it. Because I think the key is in being able to predict how you can extrapolate future tiles from that one. And as I already know that I just need to consider the odd number of tiles, and I know that it switches every time because there's an odd number shape here. There's 11 by 11, so the next time it tiles, all the values will be inverted, and then it's just a matter of knowing how to be able to predict that shape there. Let me think. Because basically I want to do like a 3 expanded in each direction, I think. I think that should be enough, and then slice up every one of them and see if we can find something about that. Whew, which is spicy to say the least. Let me see. To do that. Because I already have a sparse map of this data, I should be able to just generate one like offset to the left. If I know this one, because it's 11 by 11, the dimensions. So if I wonder if that would work. Let me test. That's an interesting test, I think. Let me do void test. Okay. Let's take this input. Let's first take this one. Test sparse like this. Okay. Let's do string raw. Is this right? This is the one that we mapped. And do this. Now I can do raw as this. It's this. And I can just no, it doesn't matter. Because this one will be my control set, and then I will do just basically this again. So what I need to do is the start marker will need to be translated. New gardens, new rocks. Let me do this, and then I do it like this, and I discard this one because I don't care. Well, I can do it like this. It doesn't matter. So I do this, apply tuple 3. Needs to be offset. Int grow size is, I want 3 in each direction. And then we do plus grow size, we do times grow size, and this one will become grid dot, okay, let me do it like this, grid dot size, and let me just make that now. I can just do public grid location size get, this one becomes rows columns. this, does an implicit conversion. And then we have something that we can work with. Basically this. And what is it complaining about? Let me just stop running right now. Grid location and int. Now, why not? Let's make that happen. Grid location. Let's do this one. Int b, so this just becomes times b. Like this, okay. So now we have, I think this should have the proper offset for start now. So let's do debug.assert start equals this. So let's start there, and then I still need to do this one and compare that, and I need to actually repeat the values for those. Because this one will now basically be the top left version. I probably need to do this -1, but I will grow it in each direction, right? So it would be 7 by 7 in its final form. So yeah, +3 would be good to offset it, so that is fine. Okay, so that one should be correct. And then I should also do the same for these ones, like for each var garden in and basically I shouldn't even do the gardens because we just want the rocks. Rock in new rocks dot to array. And then I basically repeat it in both directions. You do for int I is 0, actually 1, I smaller than grow size times 2, smaller or equal than. Is this correct? Let me think. Yes, we want to grow it 3 in each direction, so that just means that we have to do it that way. So this will be row, and do the same for column. Actually, we need to do it 0. This yes, and we just need to skip if row is 0 and col is 0, continue. This is the corner that we don't want, and otherwise we add all that stuff. So now we do new rocks dot add, and this one becomes rock dot row plus row times grid dot rows. Am I correct? Yes. Like this. And then we get the rock column plus col times grid dot columns. I think this one should do all the hard work, and then we should compare those. And then so we do rock locations dot. I think it should be like a full union, but maybe accept new rocks. And you want it like an outer symmetric with accept. Let's see. Object contains only elements that are patterned in either of the objects in the object or not both. Okay. Yes. This one modifies, right? Yes. So now we let's do it otherwise, the other way around, so that we don't break ours. Debug.assert new rocks count is 0. Didn't do a 100% expand. Okay. So I think this one should be able to get us there. This one would help to make the first smaller expansion, but I'm not sure that this is the way to go for now. Let's do it here. So we can do, I can just do test bars return like this. Boom. Okay, start 5.5. Oh, wait, what? Ah, I need to do the raw, not the input. Okay, never mind. Never mind. And this one all needs to work on this one. I was like, huh, that was weird. Okay. Start is 1616. And what do I come up with? Ah, but I expand by too much. This is just a 1x1 expand. My bad. So I need to be this. Needs to be 1. Okay, new rocks. It's 240. Haha. Okay, great. I think this is actually correct, but let's see. Before I do this, let me just run it again. New rocks is 120. And the old one was 360. So that's just 3 times as much. Wait, what? Raw map is wrong here, by the way. This should be raw, the 2 lines. Hold up, let me do this again. I need to do it like the before. Okay, my bad. So new rocks is 40, and this one is 360, which is basically 9 times 40, which is correct. Column smaller than this one. Increase column. Okay, my bad. Okay, stop. Okay, let's run this again. We have 360 there and 0. Okay, so my logic is correct now, and I can actually use this to roll up to a 9x9 map, like a 7x7 map, I mean. So what I would now do is actually do this as a 7x7 map, then run the code till it just has nothing to do anymore, and then slice that up and see what we can learn about it. But 9x9 is huge, so I will need to have a different way to print out everything, I think. So let me first do that. Bum, 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 bum. So basically this logic is fine. So if test, it's that, and then I do grow size is 3, and this just becomes let me just do this here. You can take this away. The raw map doesn't really matter at all. Let me just do if test else we do this. Okay. Now we do something stupid first. And oh no, that's actually not the case here. We want to do this whole thing, but then we want to amend it with our expanded logic. So we need to do start equals this, start equals this, and then we need to have rock locations, and then we do it like this. Okay. Now, do we grow basically this, so it needs to be multiplied by 7 in this case. Okay. Ah, haha. This is annoying. So what I need to do is actually do this. To make sure that it still works. So we have that offset there. Then we fill that all up, and then I need to do basically skip part 1 for now and run part 2. And we won't have an like this. So if we do this, it should fill up that whole thing. And 75 is the most amount of steps that it takes, and after 50 steps it did this, which is not correct, I think. Oh yeah, I should have, let me just run it for 50. Do I get the right answer here? Nope. So that is interesting. For 50 steps it should be 1594. Larger amount of steps. Ah, okay. Let's put this back in because for test. Let me see. There is correct, and this one needs to be if test. Actually, I can do test or this, and then we have, if it's test, we need to have where actually count. If it's test, we need to have the odd ones, and otherwise we have the uneven ones. Like this. We can take out this one. Better, but still too high. Which is curious. Yeah, that's odd. At least the grid is now big enough that it can take 50 steps, but so my whole logic of let me think. I was thinking, like, because of the boundary cross, maybe it now becomes no. This is an issue because it should just be able to do this. Get walkable neighbors. That is fine. Current work included. It's a bit of a shame that it doesn't work anymore now. So something that I was wondering is there a is there like a So I wonder why it doesn't work now for the larger amount of steps. Oh, did I comment that out? Wait. No, this is still here. Steps taken smaller than max steps. Could it be? No. The answer that I get is higher. Because I was wondering if, like, could it be because it hit the edge of the current map that I made that still isn't big enough? But the amount of answers should be lower, not higher. Because after 50 steps it should be able to go to 1549 94. 1594 garden plots. But my code says it's a bigger number, which is odd. Let me think. Because like the main reason is like you go to the furthest step and then everything in line, you can always take just 2 steps and get back to that point. So if you take 50 steps, any place that you've reached at 48 steps is something you can also reach at 50 steps, etc. So you could... Did I just get lucky on my on my first one? Is what I'm wondering now. Are there actually paths you can take that you can't double back to? No, because you can infinitely just go back and forth. So like how do I say this? If for like this grid, let's say you can get to this spot and you've been here and here before. If you can get to this spot, you can always get to this spot with the same number of things that you've done here, because what you can just do is you go here and then go one further and then one back again. Let's see, Amarte says, yes, just seen that. I tried to print out the map with color intensity based on the amount of times if a given spot was visited and I see no pattern. It fills out pretty evenly, yeah. But like if you reason about it, you're allowed to double back. So if you just look at every place that you can visit, like which has the same modulus 2 value, right? So if it's odd, you can visit every odd place that's seen before, and if it's even, you can visit every even place you've seen before, because you can always just, at the point that you're at, keep going back and forth 1 till you get at the amount of required steps, right? So if you want to start here and you want to know every place that you can visit with 1,000,000 steps, every place that's 2 distance away from here is a place that will be there, because you can just infinitely go back and forth to rack up all the number of steps and end up there. And I think that is true for every other place you can visit. So every place you visit with a number that has the same mod 2 as the amount of target steps is a place you can visit. So now I'm wondering, what am I keeping track of here? That how can I find things that should not be there? Is basically my question. And now I'm starting to doubt if there might still be something wrong with the way that I did this. So now I'm thinking maybe I should just duplicate this just to be sure. And actually do the manual 9x9 that I had before, just to validate that it isn't some stupid mistake that I've made. So let's do the same as we did before, like this. And then we go, we copy this whole thing. Then we set up this. Like this, so we added 3 like that, and now we need to go 3 in the other way, which is easy. 1, 2. Okay, so now this is the actual thing that I should generate. We don't need to do that anymore, so now the same logic should be fine. Boom, sequence contains more than 1 element. Ah yeah, okay, my bad. That's the, I should just do S. And remove all of these. 1, replace them by a period. So let's see, 1, 2, 3, 1, 2. This one should remain. All the others should be gone. They're hard to spot. Okay. So now there should be just one S in there. Boom. Okay. Let's run this again. Oh, it works. Okay, so my logic of how the rocks are repeated for 9 times wasn't correct, which is funny. Let's see. Largest amount of steps is 50. Yes, okay. This is fun. So now what is wrong here versus what I did before, is what I'm wondering. So now I need to actually go back and test that logic. Good thing that I had a test. Let's do test sparse 2 and see what we messed up here. Okay, no. Let's see, now we have that. I also have to fix this one, right? It might be this one. Let's see. Test sparse 2 return. Let's see. Start should be 49.49, and for me, what does it do here? 38.38. Let's see. No, it actually needs to be. Is it this one +1? What was start? 49, okay. So it needs to be times. Okay. So before I run this, rock location 30 to 40. This one is also off by 1. Let's see. Because this one should be 6, which is the last rock, the last. This is a 7 by 7, right?
I don't think... Am I this off? Set next statement. Okay. Let's run. Rock locations, 32. 22. I'm still off there. Grow size is 6. I need to do it in each dimension, which is fine. Let me think. Oh, why do I do this in new rocks? Oh yeah, okay, I need to start here. I need to take this one and then expand it that way, and diagonally. Let me think here. Wait, 1, 2, 3, 4, 5, 6, 7, 8, 9. Oh, I did this wrong. I did the expansion here wrong. This is a 4 by 4 expand then, right? Let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9. So this one, okay, never mind. I was like, this all made sense before, why doesn't it work now? Because this one needs to be 4 and not 3, because I'm a dum-dum. So now rock locations is 32, 30, 40, okay. New rocks 0, okay. So this one is now correct. So the issue was that I had a different way of growing it. So why? This is so weird to me. Okay. Let's do it like this. Let's not do this anymore. Go back. Okay. Still have that input. We don't want to do this anymore, but we want to grow it by 4 here. Okay. Is that now correct? Except I get a different answer. Let me think. Why is this not the same? What is different here? For one, I don't change the grid, which is weird, because I think that would be an issue there. Let me see. That should not be the issue there, though. (49 by 49). Sure, this is 99 by 99, so that is all correct. You have the same amount of rock locations. Start is correct. The grid is correct. We have everything mapped out. The grid is now correct. The rock markers are correct. The garden locations are never used, as far as I know, right? So what is the issue for running this? Because this one is now a bigger list, a visited list. It's interesting, because when I have the actual values there, it works. And when I take out non-matches, they are all the same. So all the values match. Right? Or did I misunderstand this one here? Symmetric except with, let's see, modifies the current object to contain only elements that are present in either that object or the specified collection, but not in both. Yeah, that should be fine. So this one tells me there is no collisions there. So why do I get a bigger number here than when I run it, when I've just parsed it? That's just really weird. This is interesting. I can take all 4 surrounding squares from my start, which should not be possible. Because if you take like the input map, there's only 2 directions walkable. So there is an issue here. Then why doesn't that other logic catch it? Like here, let me see, rock locations. There should be like if the 49 one. Well, how is this one sorted? So something tells me that the symmetric except doesn't really work as expected. Let me see, which one are the ones that we are looking for? It's like, this was a 5 by 5, right? Index 5, 5, so we need to have 5, 6 and 4, 6. No, 5, 6 and 6, 5. Okay. This. Let's debug this bad boy. See what happens here. So this is the 5, 6. Okay. So the first one we skip. Then it goes 1 over to the right. Right? Yeah, same row. That's fine. Oh, what? Grid.columns. Ah, sheesh. I need to do this after. Okay, my bad. So that is the issue there. Okay, that makes sense. So let me fix this one here. So start can be this one again. Okay, nice. And then we just update the map afterwards. Okay. Splendid. Because that just would have shifted all the rocks out of the way. Let me see. And now we get 1549. Okay. Whoo, okay. Now for some spiciness. Let's see what happens if we try to do like a big one with 5,000 steps. Okay, let's not get cocky. Let's do 100 first. I have so much inline code here. Sheesh. Let's do 100. I should actually have this in pairs or something. Be bold! Yes. I want to be brave, but not now. No, it will be fine. Let's see what this does. Okay, let's see. Okay, so I need to expand bigger than what I've done right now. So that means that let's set my growth size to 40 and be bold. Boom. Paths we can visit with 100 steps, 0. Okay. I think that messes up something. Wait. P2, Jesus. I think it's actually correct because it didn't break. Boom, that's pretty instant. Okay. Let's do 1,000. Why not? Okay, let's do 1,000. And I wonder if 40 is... Ow. But my 40 dimension isn't big enough to do this. Because it actually only lets us do 894 steps. So 40, the size 40 isn't big enough. So now we need to change 40 to, let's say 100. Boom! That works. 686,000. So, okay, so this one is still doable. So let's be bold and do 5,000, which will take a lot of time. But then you will see that this one will never happen. It's fun that we can run the test cases, right? With our very smart brute force attack. I like that this actually runs and it works fairly well. So I'm smart, but not smart enough to solve this probably. So let's see. And I need to expand further than 100 because this one will come back and say, oh, I did only 3,000 steps or something. See, in this state, 2,000 steps. Okay, so now we need to make sure that they can actually take 5,000 steps. So our 100 needs to become like 500, I think. Which just makes the amount of rocks, etc. very big. And this will work. The only issue is that what you should actually do is just keep the original amount of rocks and then do a modulus offset
against that to know whether or not there would be a rock without actually creating that rock, and always testing against a smaller value. But and that way you could also just cache all of those values, so you don't have to check it more than once. See, the 5,000 is already a challenge. Probably also to build up the list of, because it's like 500 times 500, which is a big number. So the amount of rock lists that I'm building now is just insane. I probably shouldn't have to go to quite this size, but yeah. So the next step would be to make the rock checking smarter. Okay, so this is already taking a serious amount of time. So let's see. Our current is, oh, it's near the end actually. Let's leave it running for a bit more. So close. But yeah, so calculating the test input with this method, somewhat okay, but not for the amount of steps that it needs to do. I like that I got this far though, with like not the optimal approach at all. I think I was fairly smart, and actually it works, right? So I can calculate the biggest example that they give us in reasonable time, which is 2 minutes, 3 minutes, whatever. But yeah, this is 5,000 steps. That's like a rounding error for the thing that we actually need to do. Hey, 5k to 20 mil, it's not that far. Yeah, right. Yeah. So this was fun, but it's also getting late. So I think I will end it here for now and see if I can revisit it tonight. But the next thing that I would do is not actually generate all the rocks, because that increases the complexity a lot. So I could probably get this walk down to a few seconds again, but then I could still not make this one. So there is like a way to expand this and figure it out. I just don't know if I'll have the time to do it, which is a bit sad, because like everything in me right now screams just dig in and go start and solve this, and like just close the door, lock yourself in a cave and figure this out, because I really like this kind of challenges. But my issue is that I just don't have the time to take this further than I am right now. Although I still want to just make the checking smarter here. So I think I will leave it here for now, grab another bite to eat and get some more paid work done, sadly, because I really enjoy doing this, but kids gotta eat, so I think we'll end the fun here for now. If I have another breakthrough, because the big issue that I have with these kinds of challenges is that this issue won't leave me alone now for the rest of the day. So stuff will keep brewing in my head. Ah, you're also not finished with part 2 yet? Okay, let me know. It's always nice to brainstorm. So for me, the first step to optimize this further would be to not physically create all the rock markers, but just do a modulus check there. And then what I would also like to do is see, like in every direction, I think there will be a pattern that you can figure out. So like, because it's basically a 9 slice. So starting from the start, you have, if you go up, you have this plus this, right? You have this section, and then this one is pasted on top of it. And that one will repeat forever in that direction. So I think there should be a way to, like, if you calculate offsets based off relative to the first time, I think you will always have like similar distances between the way the tile maps. So I would want to do something like that, and that you have to do that for each direction. For this half, so like at the symmetry point going that direction, I think there will be something there that you can work out. I just don't know if I have the time to actually work that out, which bothers me a lot. Let's see. Amarthe says that's what I was searching for. Pasted image on Discord for some patterny behavior. Okay, let me look. Let me quickly look. Haha. Ah, these are the counts. Well, that's interesting. You can see actually a diagonal pattern here, right? So you actually have the data there. You have the diagonal pattern repeating, the 1 6 7 6 here, and the 1 2 3. And the 21 23 here. That's what I was searching for. Exactly, yes. So there is, and I think it's like, the funny thing is that from here on, I would expect that the straight angles would stabilize. Oh, but you do. Yeah, let me see. You have like, what are you recording here exactly? Because this is like the Manhattan distance thing again. Like this one is the same as this one because you can take the same amount of steps, right? So this is like a perfect circle radius. That's interesting. Start point is not symmetric on the tile, so vertical horizontal won't stabilize. Well, my reasoning. Ah, okay, like that. Yeah. Ah, you could have a walking there. Okay. Yeah, because my reasoning is you will encounter the same thing over and over again. So what I was thinking was that like the relative distances. So if you take this half here, right? Let me just take this here. Come on, come to that. If you take this part, then this part will come after it, and then this one will repeat to infinity. And my reasoning is that relative to this point, all these points that it encounters the first time going up, if you extrapolate that, it would be able to have a relative, like within a tile, relative distance to repeat. And that's what I think might happen. But I will... Man, I really need to get some other stuff done. But I really want to do more work on this because I really like this idea and like this challenge. Let's see, that's the total sum of all spots visited for each tile. Okay. Okay. So I will end it here. I've had a lot of fun doing this. And hopefully I can come back to it and do some more work because I think I'm really close to finding a solution. I have all the mechanics in there already to do stuff efficiently, so I think for now it would just be a matter of visualizing and analyzing relative distances and counts. Amarthe says, so okay, so maybe later, have a good day. Yes, thank you to you too. So thank you everybody that watched the stream. It's always nice to have people enjoy the stuff that I do. Yeah, I will get back to this hopefully maybe tonight or tomorrow. And if not, tomorrow is a new day that we will do Advent of Code. So have a good time and thanks for watching.